Hi, I'm Ryan Fantus with Latent AI. Today we'd like to show you a couple of different capabilities that our tools can help bring to operators working out in the field at the edge. The first demonstration that we'd like to show is one that is in a ship harbor. Essentially what the operators need to do in this case is deploy a sentry, which is represented by this screen, by this video playing right here. And that's supposed to be a live feed of ships in a harbor. The operators need to be able to see when ships are coming in without manually staring at the screen. They need to be able to see callouts. They need to be able to have data about that. This model that's running right now actually is not detecting anything. You can probably see pretty clearly that there are no bounding boxes, no detections. This is something that you can kind of expect when a model ships from a higher headquarters and then gets out to a location where they don't have the actual data needed for that operational environment. Right now, this model is not meeting our operational needs. It's not showing any sort of detections. And so the operator at the edge needs to update this. Typically, that would consist of deploying an entirely new model. So that could be up to 500 megabytes, sometimes even more. In this case, what we want to do is we just want to patch the model that's running in memory. So what we have here is a patch, and you can see this patch is about 22 megabytes. So that's going to save a lot of bandwidth. And you'll see also it saves a lot of time with actually patching an already running model. So right now, this model is actually being patched with that new update that we've just deployed. It's patching in the background, requires zero cognitive load from the operator. And you'll see that in almost near real time, the model starts detecting things as we expected in the first place. So we basically took a 500 megabyte model. We didn't have to reship the whole thing. We just reshipped the little tiny bit that was required to make it do the functions that we needed it to do. And so that essentially concludes the first portion of the demo. So let's go ahead and move on to the second portion of the demo here. The second portion of the demo, just like the first, is running just on an HP ZBook laptop. It's not running on a GPU cluster or anything. And what we're using in this case is we're trying to make the LEIP products help operators create labeled and curated data sets. The reason that this is important is because without a labeled and curated data set, you can't retrain a model. But a lot of times it's difficult to get a new data set that is labeled and curated. And oftentimes it requires a lot of images, a lot of processing, and a lot of mental bandwidth to actually go through every single image and update, label it. And so I'm going to show now how we try to make it so that operators don't devote that much time and effort to doing the same work. So right now what we're looking at is basically the ocean floor. This is a side scan sonar. And the intent here is to find objects that are along the ocean floor. What we eventually want to do is we want to categorize these objects and use those as a labeled data set for a retrain purpose. So we'll start with this find everything function from the LEIP tool. The find everything function is basically looking at the ocean floor and is saying, show me everything that doesn't belong here. Show me everything that's not just ocean floor. And so you can see, for example, that we've got an object that has been detected here. And it's an anchor in this case. And so let's say that we want to add anchors to our model. And we know that we've got a large data set. We'd like to see if we have any additional anchors that we could label with as little cognitive load, as little manual labor as possible. So previously we used the find everything function. In this case, we're going to select this anchor and we're going to find similar. So now instead of looking at the results of find everything, we'll look at the results of find similar. And again, it's honing in, it's indexing on that anchor shape. It's looking for things that look like that, resemble that. So one thing we want to do is manually set a threshold. This is where we still keep the operator in a loop. We still want the operator to say, this is within maybe 80% accuracy, similarity to that initial object. To me, that's probably good enough to start looking through some of this data. So we can change the confidence level manually. I set the confidence level around 80%, and you can see that really shrunk the potential data set. So now I can go through and I can manually look at the resulting data, and I can curate that and label that as needed. So I can click through and iterate through each one of these images that it pulled out, confirm that the similar object is actually an anchor, and then I can apply the anchor label to that data set, extract that, and use that for my retrain. So that concludes what we'd like to show today. Feel free to check out more on our YouTube channel. Look for Latent AI or check out latentai.com.